Okay, welcome back from break. And so before we left for break, we looked at distribution, all right, what we call the distribution, and we looked at the mean, and then we also looked at the standard deviation, all right, of concern. We highlighted more on the standard deviation, where we said that the larger the spread, the larger the standard deviation, the lower the spread, the lower the standard deviation. Okay, now we are going to look at what we call the empirical rule, and this is a rule, right? I know we all know what a rule is, and we are going to use this rule to deal with a number of problems under the normal distribution or the bell-shaped curve, okay, or the symmetrical curve. That's what we're going to do. So this is a rule, and we have to know how to use this rule most appropriately. Very significant. Okay. Now it turns out that all normal distributions have the characteristics described on this page. So now the diagram on the page are normal curves with a mean of, so the mean is represented by the Greek symbol called mu, and the standard deviation will be represented by another Greek symbol, sigma. Is that okay? No. Now notice the mean is at the center. Adding one standard deviation to the mean would be mu plus sigma. Subtracting one standard deviation from the mean will be mu minus sigma. The area under the curve represents the likelihood or probabilities. Now, we have said that the whole area under the curve is 100%. But let me tell you, let me break this into simple terms. Okay. Now, you remember in elementary school, you dealt with the number line. So the number that sits right at the center is what you call, is what? 0 for a number line. And the number, and if you move 1 unit to the left, numbers to the left take what? On negative. And numbers to the right take on what? Positive. Is that okay? So in our case, this time, we are just upgrading, we are just building up. So we are saying that the number that sits at the center is called, instead of saying 0, we call it the mu. Is that okay? And we are saying that this number minus 1, because here, what did we do? We did 0, because we moved 1 unit to the left, we did 0 minus 1. And because we did 1 unit to the right, we did 0 plus 1. So we are saying that this step we made to the left, this should be mu minus sigma. Okay, now, and we are calling this, and we move that, this is mu plus sigma. Is that okay? And we call the first movement the first standard deviation, because we add and subtract sigma on both sides. And I'll take you here. So this what we call the first standard deviation. So this is the first standard deviation when you move 1 step to the left and 1 step to the right. Okay, and we are saying that approximately 68% of the values are within 1 standard deviation of the mean. And we are saying that the area for 1 standard deviation is what? 68%. So this is 34%, because this is symmetrical. If you break this up, it's 34, that is 34. So the rule is 68%. So that's the first standard deviation is called, is what we have as the 68%. Okay. Now, the second standard deviation, we are looking at that. So this is first standard deviation, and this is second standard deviation. Now, second standard deviation is when we move 2 steps to the left and 2 steps to the right from the origin, right? So here we have 0, 1, and what? 2. But what did we do? Because we moved 2 steps away from the center, we did 0 plus 2. And that is why we have here to be 2. Now we are saying mu is what? 0 is our mu, and then 2 is our, so we do 2 sigma. And then we do the same steps to the left. okay? And we do mu minus 2 sigma. Is that okay? And that is why we call this is the 95% rule. And we call that 2 standard deviations, okay? So the first one is 1 standard, this is 2 standard deviations. And then when we do the third, okay, so 0 plus 3 is 3. So our mu is 0 and 3 sigma. Okay, we move 3 places and we have mu minus 3 sigma. And that's what we call the third standard deviation. And the percentage for that is 99.7. So this idea is from our basic elementary rule that we know on the number line. Okay, and we are using that to espouse on this. Now let's get into it. Okay, so this is just an introduction to the empirical rule. Now let's get a little detailed with how you can really use this. Okay, nice. So if I break these percentages down, I told you that, so the first standard deviation was what, 68. Now 68, if you break 68 into 2, you have 34 and 34, right? So that is 68. So 34 and 34 on both sides. Now, the second one, which is the second standard deviation, okay, that is 95. Now between this and that, we have 95. So now don't forget that we are dealing with asymmetrical data, right? So if this is 68, and because this is symmetrical, what is here is the same as what is there. So I'll say if we don't know that. So we know that the whole distance is 95%, but we didn't know the value here. So I'm showing you how we came by this 13.5. Now, because it's symmetrical, we have the same area here, the same area there. So if we decide to put this together and equate to 95, we can find our x. So x plus 34 plus 34 gives us 68 plus another x. And the whole area is what, 95, equal to 95. So we have 2x plus 68, okay, is equal to 95. So 2x is equal to 95 minus 68, okay? And what is 95 minus 68? That is what, 27. We divided by 2 and divided by 2. So x is 13.5. So that's why we have 13.5 right there, 13.5. So really, we've just broken down these percentages, okay? And we have that. Now, if you wanted to find that, we do the same thing, because we are saying that third standard deviation is 99.7. Okay, so here between this and that is 99.7, right? So we put everything together. Now that we know that, and assume that we don't know that, we put x for that and x for that, and equate the result to 99.7. We realize that the final result is going to give us 2.35. So we have really broken down these percentages into individual regions, and that's what we've done basically here. Is that okay? Now, for you to get problems under empirical rule done, you have to be able to produce this table. You have to be able to produce this table or assign the percentages to this diagram. To be able to use the empirical rule, you have to be able to assign the percentages to this diagram. Now, the good thing is that you can easily memorize this, because this is symmetrical. If you know half, you should know the other half, because this is 34, that is 34. 13.5, 13.5, 2.35, 2.35. So if I were you, I would just memorize half. So if I know this half, I know the other half. Okay, nice. So let's go further and see how we can get through with this. Now that we know how these percentages came about, now let's answer the following questions under this diagram. The area under the curve to the left of mu minus sigma. So the area under the curve to the left of what? Mu minus sigma. That means we have to put all the percentages here together to the left of that. So we will do 0.15 plus 2.35 plus 13.5, and that gives us what? 16%. So that's the area to the left of mu minus sigma. Okay. Now the area under the curve to the right of mu plus 2 sigma. Say so to the right of mu plus 2 sigma. What area is there? So you put 2.35 plus what? 0.15, and that gives you 2.5. Okay. Now, if all the percentages in the diagram are added together, now add all the percentages on this diagram. If you add all the percentages, what do you have? 100%. Okay. Now the area under the curve to the left of mu plus 2 sigma. So the area under the curve to the left of what? Mu plus 2 sigma. Now half of it is what? 50%. So what do? I just do 50%, which takes care of the half, and then 34, that is right there. And then 13.5 and half, that is what? 97.5. Okay, if I want, on the flip side, if I put this and that together and I take away from 100, that will equally give me that area to the right, to the left of mu plus 2 sigma. Do you see that? Okay, sweet. Nice. So quick. So basically, typically this is how a question will look like. Okay. This is how a typical question will look like. And you have to be able to get through with this. So how? Here, you have the mean and you have the standard deviation. So your mean is what? 66.70. And your sigma is 9.41. These are temperatures, okay? Now, where do you think the mean, the mean will go? So the mean goes right at the center, right? So 66.7. The center is your mean. Now, the standard deviation is given to you as 9.41. So you have to complete this table. So use the mean and value to label the values on the lines above. So here, if I move one step to the right, so here I'll add 9.41. And what do I get? So 66.7 plus 9.41. What do I have? So this gives me what? 76.11. So when you move towards the right, now here, if you move towards the right again, you add 9.41 plus 9.41. So this should give you what? 85.52. And then you add to get to the third standard deviation plus 9.41. And that is what? 94.93. And don't forget that you have to do that. You have to add that. Now, because you are moving to the left, so here we move towards our right. Now we are going to move to the right, to the left, right? So we have to subtract. So here we take away 9.41. So 66.7 minus 9.41. What do we have? This is what? 57.29. Now we are going to subtract as you move to the left again. Minus 9.41. And this is what? 47.88. Then we subtract again. Minus 9.41. And this is what? 38.47. Okay. And you are almost done. So that is what you have to do to complete the table. So it says use the mean and standard deviation to label the values on the lines above. And that is it. Okay. Now, don't forget, you remember that you have to know how to assign these percentages, right? So I said, if I know half, this is 34%. Okay. How about this? What percentage is assigned to the second one? And this is what? 13.5%. And this is what? 2.35. And this is 0.15. Okay. And if I know the half, I know the other half because this is symmetrical. Okay. So these percentages should not be easy to do. Should not be hard to do. Sorry. All right. Now it says approximately 95% of the days of September will fall between what two temperatures? Okay, and don't forget that 95%. So here I did that. 95% is the second standard deviation. So this is the first standard deviation, and that's the second standard deviation, which is what? 95%. So this is what we want. So the 95% values will be 47 and 85.52. So you don't really have to do any calculations after you do this. So approximately 95% of the days of September. So you are using the empirical rule, which is what? 68%, 95%. So 68% is the first standard deviation. Okay. And then the second standard deviation is 95%. So we just want the range of values. So you quote the answers, the numbers you have right there, and the numbers you have right there. Now, how likely is it that a September day temperature will be warmer than 95%? 95 Fahrenheit. Sorry. How likely is it that a September day temperature will be warmer than 95 degrees Fahrenheit? Look at it. Now, these are temperatures. So a September day temperature, the likelihood will be within that region. Is that okay? So you say that that is very unlikely, less than 0.15, because the region here takes the percentage what? 0.15%. Is that okay? Now, based on these values, how many days is September? In September, could we expect the temperature to be less than approximately 57%? To be less than approximately 57, to be less than that will be what? Here. Okay. And now, what do you think that is? So if you put these numbers together, 13.5 plus 2.35 plus 0.15, that gives you what? 16%. Now, how many days are there in September? 30 days. That's September, right? So you do 16% of the 30 days in September, and that gives you 4.8. That's approximately 5 days in September. Is that okay? So this is really cool. That is so fun. Can we go to the next example? Okay. All right. Thank you. Nice. So here we look at this example that talks about a popcorn company builds a machine to fill 1 kilogram bags of popcorn. They test the first 100 bags filled and find that the bags have an average weight of that 1040 grams and a standard deviation of that. So we know our mean to be 1040, and we know our standard deviation, which is sigma, to be what? 25 grams. And we know that our mean always go to the center, right? So 1040. And then when we move to the right, we add the standard deviation of 25. Okay, so this will be what? 1065. And then when we move again, we add 25, the standard deviation. So 1065 plus 25 gives you what? 1090. Okay. Plus another 25, and that gives you 1115. Okay. Now, so we move to the right in these instances. Now here we have to move, we are going to move towards the left. So we have to subtract minus 25. So we have 1040 minus 25, and that is what? 1015. We move to the left again, and this is what? Minus 25. And that is what? 990. We move to the left again for the very last time. Minus 25, and that is what? 965. And we are done completing the table. Fill out the normal distribution curve for this situation, and we've done that. Isn't this easy? That's it. So you've done the first part of the question. Now, the middle 95% of people would receive backs. Now, don't forget that when we talk about the middle 95, we are talking about the second standard deviation. And we know that on pages 192, the second standard deviation is this number, and what? At that number. So we just want the range of values, okay? Because we know this is the first standard and this is the second standard deviation. And we just want the range of values. So the range of values is all we want. And that is 990 and 1090, okay? Now, what proportion of customers will receive backs at least 990 grams? At least, the least 990, right? So we have to look at far right from 990. So we are looking at that, the proportion of customers that will receive at least. Okay, so we know the percentages. We know this is 34%, okay? And we know that this is 13.5, and we know half of this is 50. So that's why we have 50 there. Now you put these numbers together, and that gives you 97.5. Sounds good? Gucci. All right, now estimate what percent of customers will receive bags less than 1 kilogram. Less than 1 kilogram. And less than 1 kilogram. 1 kilogram is what? 1,000 grams. Okay. And here we will discuss this in detail when we get to z-scores, because we want to be specific. Less than 1,000 should be somewhere there. Okay. But we will discuss this in detail when you get to z-scores, because when you use z-scores, we get the exact answer rather than using these percentages. Okay, so we will look at it in detail. Now, right, so that is what we will do. Okay, so I actually brought the practice problems for these problems here, just so that it will complete the whole discussion on the empirical rule. So if you are in your book, I actually brought, these are problems on pages 203 and 204. They are part, I brought them here to enhance this discussion, okay, and to make the conversation more complete. Okay, so the mean is giving us that, and the standard deviation is giving us that. Can you fill this table? So go ahead. So the mean sits here. All right, so we have our mean to be what? 27.5, and our sigma is 5.2. So go ahead and complete this table. So fill out the normal curve. So fill this out. Okay, I'll give you 5 minutes to do that. Too much time. 2 minutes. 1 minute. Okay, did you produce that? Nice. So you produce these numbers. And what is the interval of commute times of the middle 99.7% of students? And 99.7% is what the third standard deviation. So here we are looking at the third standard deviation, and these are the values for the third standard deviation. So we just want the range of values after you complete the table. Okay. So if you want to recollect that, that is on pages 192. So the third standard deviation is between this range of values. Now, what is the probability of a commute time being more than 38 minutes? So the probability of a commute time being more than 38 minutes, okay? And that is don't forget this percentage here is what, 2.35, and this is 0.15. Now, 2.35 plus 0.15 will give you what? 2.5%. Sounds good? Nice. And based on this data, how many students out of 500 would expect their commute time to be less than 12 minutes? Less, isn't it here? Less than 12 minutes. And what percentage is assigned right there? Just what? Okay. So what do? We want the number. So 0.15, we change that to a decimal, we multiply by the 500, and that is what? 0.75. We want the number. How many students? Is that okay? So we multiply out of 500. So we multiply that 0.15% by 500, and we have 0.75. Okay. Nice. Now let's look at another example. Now consider the birth weight data, which is bell-shaped with a mean of that and standard deviation of that. Okay. So are you able to complete this table? Okay. So go ahead and fill out, label the bed weights, okay, at the bottom of the normal curve below, rounding to 2 places. Go ahead and get this done, please. Okay, so put the mean, and so you have 30 seconds to do that. All right, okay, so this is what we got if we produce these values. Okay, now, did you get the same values? Check, 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 check. And 95% is the second standard deviation. Okay, the second standard deviation. This is the second. So we just want these values at this point. And what's the probability a baby will weigh less than 5 pounds? Less than 5 pounds. Less than 5 pounds is right there. Okay, that region. So what do? You put these percentages together, and that gives you what is the probability a baby will weigh more than 5 pounds? More than 5 pounds. So more than 5 pounds is the whole region, right? So half of it is 50%. So 50% plus 34 plus 13.5. Okay. And that is 97.5%. Okay. So yours is to fill out these values. And then don't forget to put in these percentages to guide you to solve these problems. And again, you have to be able to memorize this. Find an easy way to do it. And I showed you an easy way to do that. Okay. And approximately how many babies out of 1,000 will be born would you expect to weigh more than 11 pounds? Okay, so you multiply that by the number, and that gives you that. Okay, so basically, that is all. This is all I wanted you to know under the empirical rule. Is that okay? So far, under the empirical rule, okay, you should be able to draw this guy. Okay, and know that your mu will be given, your sigma will be given, and this is it. You draw this, so your mu is right there, and this is mu plus sigma. This is mu minus sigma. This is mu minus 2 sigma. Okay, and then I have mu plus 2 sigma. And the third one is what? Mu minus 3 sigma. Okay, and mu plus 3 sigma. And these will be given to you. So just plug them in to complete your table. And know that this is 34%. You have to know that percentage. And this is 13.5. And this is what? 2.35. And this is 0.15 right here. Now this is symmetrical. So whatever you have here, and you only need to know half of it. Okay. So now you realize that this is also 34. This is 13.5. This is 2.35. And this is 0.15. And we have said that the first standard deviation, this is 68%. The second standard deviation, okay, is what? 95%. And finally, we have said that the third standard deviation is what? 99.7%. That's all you should be able to produce this, okay? So thank you very much for your time, and I will see you soon to discuss z-scores and percentiles, okay? So thanks and see you soon. Bye-bye.